Hello, my name is Richard Stepp, FDOT Central Office in Tallahassee. This last ebook cycle, I was primarily responsible for updating following standards. So we made some updates to Guardrail, the guardrail connections for existing bridges, crash cushion details, and adjacent barrier inlet. And so now I'll walk you through some of those changes. And so up first for Guardrail, index 536001, this is our longest list of changes. We've removed modified Thri-beam. We've removed flared approach terminals. We specified approach terminal clear area requirement. We have a new single face to double face guardrail detail, curb connection details covering all options now for connecting to a rigid barrier. We have a frangible leave out requirement. Now we require steel post only, and then we've got some new SPI and design tool updates. So starting with sheet number 5, we removed the modified Thri-beam. So modified Thri-beam was removed in coordination with the 2020 FDM removal. And the reason for this is under our new MASH criteria, it really wasn't giving us a different test level than standard W-beam. And modified Thri-beam requires different type of connection details, requires project-specific details, and so there was a little bit of extra complication there. So in order to avoid that and have it be compatible, having all guardrail be compatible with end treatments, we're now just going to stick with the simple W-beam guardrail because it covers the same MASH test level. And then also for TL4, our single slope concrete barrier covers that MASH TL4 option. Now on the same sheet, we've added in a new detail for going from single face to double face guardrail or vice versa. This particular sheet going left to right shows double face going into single face. Some of our QARs had shown that sometimes designers hadn't found this type of transition in our example. And so they might have been ending it with an end treatment or something like that. And so to make this policy more clear, we just went ahead and showed a nice blown up detail for it. Basically, it just ends with a flared end unit. So it's pretty straightforward, but now that's covered there. So now in the plans, all you'd have to do, for example, here going from double to single face would be call out end double face, begin single face guardrail at the same station. And then the rest of that's covered for you. The one thing I want to mention when you're doing a transition like this is just to make sure that the back side of the single face guardrail and the ending W-beam panel is outside of the clear zone on that particular side. So we know the back guardrail is not crash worthy, the posts are not crash worthy. If the vehicles are coming directly towards the end of this panel, and this is not considered crash worthy either. So generally you'd be going away from double face to single face when you know you're outside of a clear zone and it's no longer an issue. And so I just wanted to mention that. Okay, so sheets 7 and 8 now, we're getting into talking about our approach terminal. We're showing some of our approach terminals on the APL. And so looking at sheet number 7, which is our standard for approach terminal, we've removed the flared approach terminal option now. That comes from Roadway Design Bulletin 1802 requirement. They're no longer used on new projects. This corresponds to changes in the FDOT design manual, the SPI, the basis estimates, the pay items for parallel approach terminals have been sunset. And even our Excel design tool no longer shows the flared option. So it's a pretty sweeping change. And then the reason for this change is, following our new MASH criteria has larger vehicles. The industry is finding that a little bit more challenging to meet the MASH requirement. They've been able to do it with a lot of parallel terminals, so we have plenty of options for that. But there really just aren't enough options right now for flared terminals, so we went ahead and removed that as an option. Okay, so we see the updated sheet now. We now just show only parallel option in both the plan view and the section views. And so additionally, on sheet number 7, this was always implied in the drawings. We now have specified the clear area requirement around an approach terminal. And so The idea is that really anywhere you have the slope shown that's a 1 to 10 or flatter, it was always implied that the reason for that is so the vehicles could easily traverse that, and then the approach terminal can perform as it's supposed to. But as another part of that requirement now, just to make it clearer, we now have defined a clear area requirement on note 6, which basically explains any place with a 1 to 10 or flatter needs to be free of above ground obstructions. That includes dense vegetation and trees. And so the whole idea is to emulate the best we can crash test conditions so that nothing unpredictable is happening around the approach terminal. We don't want any vehicle instability there. And so the idea is to keep it, especially upstream of the approach terminal, nice and free and clear of above ground obstructions. And yeah, so the whole idea is, upstream, you follow that 1 to 10 all the way back to the slope break point, keep that nice and free and clear of obstructions. Okay, so the next topic we have is approach transition connection to the rigid barrier. That's where we're increasing our rigidity as we approach the concrete barrier or the bridge traffic railing. And so we'll go ahead and take a look at the standard for that. So on this is now, we consider this kind of like the default sheet that shows the introductory details, the plan and elevation, because now we're going to introduce additional sheets which show the more complex curb options. So because of that, we now show as a default that this alignment curb now ends with the simplest flush shoulder option. So it's basically ending with a no curb option by default on this sheet. So that's one change, whereas before we had showed an example of a shoulder gutter option. Now the shoulder gutter option, the raised curb option are going to be provided on this next sheet to follow. So we modified this to show the simplest option. One other thing that we've added is now the parallel requirement for the approach transition connection is now has the entire dimension delineated for it. This is helpful for designers now, rather than having just to add up the post spaces. We just went ahead and gave a hard dimension. So from your begin of guardrail measurement to the point where the taper can begin, we went ahead and called out your 28 feet, 1.5 inches. And now as a reminder, the taper location here is where you would start transitioning to the FDM offset. So for a flush shoulder, it's typically your shoulder width plus 2 feet, the FDM requirement people are familiar with. So you keep it parallel to the rigid barrier shoulder line you're connecting with, and then after that dimension, you go ahead and start tapering over. So now that's called out as a nice hard dimension. Okay, so now looking at the new sheet, this is now sheet number 14, the curb connection options. We show the shoulder gutter connection and the type F curb connection options. So this would be your shoulder gutter on top and the type F on the bottom. And so these are now expanded plan views. And the idea is it takes you from the parallel segment of the approach transition connection through the taper, and then it takes you to the typical guardrail section that this would be shown on sheet 6, and then also in the FDM up here coming from left to right, this would be your shoulder gutter section. And so we just explain how to get to that. So it's detailed out for a contractor. In the plans, you'd want to emulate this, but now I think the dimensioning is not quite as critical because the dimension is called for, and then the taper rate's also called for. And so for example, we'll zoom in on one of these options. So looking up close at the shoulder gutter option, we can see that we have our parallel segment called out, similar to the default plan view we've already looked at. We then have the tapering segment. It shows 1 to 15 max because this happens to be TL3. For TL2, it's 1 to 10 max. It could be a little steeper, but that's we went ahead and drew that. We use the exact number of post spacings that be required to meet 1 to 15, and then have the guardrail beginning its curve or its taper at post locations. So we basically rounded it to the nearest post location. And then now we have the parallel guardrail continuing on. If you look at sheet 6, this section looks exactly like this for a shoulder gutter. And then last, our section views are called out. These all correspond to the section views that are shown on 17. We've got some good detail in there showing exactly where the post goes in relation to the curb as it's transitioning. So contractors can follow along with that. Okay, so moving on to new number sheet 16. This is the new sheet that's similar to the one we just saw, only now it's for TL2. And if you recall, a TL3 is used for all design speeds. TL2 can be used for 45 miles per hour or less. For lower design speeds, you would expect you could save some posts, which is shown here. You could save some nested panels, and so there's a little bit of cost savings involved with TL2. And so this is the same as TL3, only TL2 option is a little bit shorter. Main difference is this approach transition connection length is a little bit shorter for TL2, and then also the taper can be a little bit steeper, so it's 1 to 10. So that also saves you a little bit of overall length in the system. And then just like the other example, when you get over here on the right side, these are your typical guardrail sections, so it's the same. And then last, same as TL3, these are identical cross sections for simplicity, and these also correspond to sheet 17. And then one thing I'll mention, since we're looking at both of them on the same sheet, basically sections A through D are all identical for approach transitions. Section E, F, and G are all now going to change on sheet 17 depending on what your curb option is, and we'll show you that now. So looking at sheet 17, as we were saying, the letter sections correspond to the plan views we've seen in the previous sheets, and now each curb option has a unique section lettering. So for example, section EE is a flush shoulder option. That's kind of like the simplest default one we've shown. And then this also corresponds to the isometric. So you have the raised curb, you got the alignment curb that's always required. And then here's your curb transition. And then this basically just ends into the ground. And then from that point on, it's a flush shoulder. And section EE is even called out in the ISO to correspond here. So the contractors can follow that. For the shoulder gutter, section FF, you can see again, got the isometric, and then it ends right here, which corresponds to the section view. It's also shown in the plan and elevation on the previous sheets. And then same thing for section GG. We have the ISO, all the sections correspond. All right, so with that, we'll move on to a different topic. This would be the modified mount. This is the frangible leave out, which is typically used for mounting guardrail in concrete when you have solid concrete. The idea with the frangible leave out is so the post can move when it's impacted by a vehicle. So there's a softer material that's placed around the base of the post. We use flowable fill. But there have been a little bit of changes with this standard, so I'm just going to make you aware of that. And basically what we've shown here is we've removed the timber post option. And so now moving forward, only steel posts are permitted. MASH crash tests have shown that steel posts are more crash worthy than the timber. And so now we just require the steel post is used for all cases. I think it's able to slice through the soft material a little bit better and then deflect and perform as it's supposed to. As a designer, you may just want to be aware of that and specifically call out steel posts in the run, of guardrail upstream and downstream. Frangible leave outs just for consistency. It's preferred just to have the same post throughout. Okay, so now one other thing, we've always in the past few years had the policy of calling out at the same location either the end treatment or the approach transition connection and the begin or the end of guardrail. It's always the same station for simplicity. And now I just want to show you a few examples of how we've just made this more consistent throughout our standard plans. The examples always show this, but now we're just going to show this in every single location in the standard plans. That way the contractor and everything kind of corresponds, jives a little bit better. So here we have approach terminal, begin and guardrail station, both at post 1. That's how it's now labeled in the standards. So then that would be very similar to the way it shows up in the project-specific plans. So similar, CRT end treatment, same thing, CRT end treatment, begin and guardrail station, same location, post 1. And then on the other end of guardrail, where you'd be connecting to a rigid barrier, that corresponds to the bolt hole location, because you're going to start measuring all your panel lengths from the center line of that splice. So here, this happens to be a TL2 approach transition, and then beginning and guardrail station are called out in the same location. So that's just a reminder of the way things are called out with guardrail for simplicity, and now the standards just happen to show that in every location as well. Okay, so with that, moving on to standard plans instructions. I have a few updates made here as well. So as with the standards, we removed the approach terminal, or flared approach terminals. We've removed modified thrive beam. We've added in minimum guardrail length details. We've added in radial guardrail guidance, and then miscellaneous clarifications throughout. So this example 2 all happens to be on one sheet. There's a few other examples that will show you that come below this. But essentially, we're showing now minimum guardrail lengths when you're connected to a rigid barrier, either concrete traffic railing on a bridge or concrete barrier. And if the sole purpose of installing this guardrail is to shield the end of the concrete to make it crash-worthy, we want to go ahead and provide what would the minimum length of guardrail be, what components are necessary. And so just as a reminder, you need, in order to shield the concrete, you need the approach transition connection to rigid barrier, which transitions the rigidity, and that's a standardized length. And then you need to add the approach terminal on there. And then so those two lengths together are the overall length you need. And then for a little bit of clarity, convenience, we went ahead and made an example just showing all the minimum lengths and how they work out together. And so as we were saying, the length of approach transition connection, LA, it's a little different between TL2 and TL3. These are standardized. So now you just need to know how we're going to get the overall length by using the LA as part of that summation. And then LE also changes depending on TL2, TL3, a little bit shorter for TL2. And then so there's a couple lengths given where we have one length given from the beginner end of the rigid barrier to the overall end, including that impact head. And that's so the overall length, basically your space requirement is the top dimension. And then as the call out show, this dimension here is your overall length for your guardrail stationing. So your guardrail overlaps the barrier just a little bit. So we took that into account. You got your beginning of guardrail station and then your end of guardrail station. And so that's just a nice convenient number. You can grab that from the example next time you're connecting to a rigid barrier. And so now also on that same sheet, we called out the case of shielding the rigid barrier with the radial guardrail. And so what are the bare minimum lengths that you can use for this? And so we gave all the same similar call outs that we did for the parallel version. The main difference between TL2 and TL3 is the approach transition connection length. And so we took that into account. All the rest of the variables are similar. And so I won't get into too much detail here, but you can look at this if you're trying to use a radial guardrail. You may want to be using this if you have a canal hazard back here. You might have a side street very near the end of the bridge or a driveway or something like that, and so a radius just makes more sense. And so now you know your minimum lengths and offsets that you're going to be required. And so on that same topic of CRT, we've added Part M to the SPI that's called radial guardrail, and we got into a little bit of a description of reminders of things that you need to do, that these are already standardized requirements for the most part, but we just added the reminders of what you need to look at in the standard to make sure that you're emulating the standard, because it is important to have it function correctly. So one requirement we've added in is that the angle between the linear segments, which go along the primary roadway and then the secondary roadway, side street, or the driveway, these are the two parallel segments. These need to be 90 degrees plus or minus 15 degrees. There's almost no real world scenario that has exactly 90 degrees the way the standard shows it. So we do allow for a little variation. Going greater than 90 degrees is probably preferred to capture vehicles, but you could also go a little bit less if it's needed. The clear area limit shown in the standard, it's very important. There's no above ground obstructions behind here. These are all breakaway posts, and the way that the system functions is breaking away to absorb the energy, and it kind of goes deep into the clear area limits. And so if there's above ground obstruction, it's likely it's going to be hit. And so we got to make sure that you keep that clear. And so we put a reminder in the SPI. And this perpendicular segment is also important as well. This is the way it had been crash tested. Because these are all breakaway posts, you need a lot of them to capture a vehicle. Otherwise, it's just going to be kind of like a gating system, and the vehicle will go right through, and it's just not going to be helpful. So because of all the breakaway posts, you need a significant number of them to capture the vehicle. And so this 25-foot segment, which is shown in the standard, is important. And we understand, it is tough to meet that, but it should always be a goal if you have the space. So one other thing we've added to this radial guardrail segment is to say that if the previous CRT requirements can't be met, if no other options exist to remove or shield a severe hazard, then a general guardrail radius may be installed. And so we wanted to give another option for a low speed condition. If we know there isn't enough space for all the breakaway posts, and then the CRT system is not going to be really effective, the designer can have an option to put in basically standard post and offset blocks that are not breakaway. And at that point, all you're really doing is just putting in a buffer, because it's just all you have room for, and it's the best you can do as a designer between the vehicles and maybe a canal hazard or something worse, or a severe drop off. So we went ahead and mentioned that you can include just a general guardrail radius if you provide a justification for it in your project documents. And so there's more information on that in SPI Part M. All right, so with that, move on to Index 536002, guardrail connections for existing bridges. And here we've added a new trailing transition connection for existing connections, and then made a few other graphical changes. And so the first thing we did throughout was to eliminate the flared approach terminals. They were shown visually throughout. As a reminder, flared approach terminal is no longer permitted per this design bulletin 1802. So we made that change throughout. This is the way the new one looks. They're all now parallel. And then one of the larger changes, we've added in specific details now showing the trailing end of an existing bridge. And this is on the downstream end. And so it's very similar to the approach terminal. I'm sorry, the approach transition we show on sheet 27. The difference is because it's trailing end, you can see that the direction of traffic is very specific, going away from the end. So we're not concerned with a vehicle's direct head-on impact with the concrete. We're not as concerned with snagging, and for that we can have a much lighter design. So we just go straight into 6'3" post spacing. No nested panels are required, but similar to the approach, we do have the 3 schemes, for either bypassing or connecting to the wing post. So if the wing post is sufficient, you can connect to it, or you can skip over it. So it's very similar to the approach, just trailing is a lot lighter design, and so now it's a little bit more clear on how to handle that scenario for existing bridges. Okay, so moving along to crash cushion details, we now have a short guardrail extension option. And so just going to go through kind of a lot of information on this just so you get a feel for when you would consider using a short guardrail extension. And so it's really kind of the intermediate option between either if you did choose to shield the end of a bridge traffic railing with permanent crash cushion, it's the intermediate option between putting the crash cushion, mounting it directly to the end of the concrete, or using the full standard guardrail transitions to W-beam, from Thrive-beam to W-beam, and then from W-beam back to Thrive-beam again, which might not be practical, might be too long. And so I'll just walk you through the concepts again so you get a feel for it. So basically, when permanent crash cushions are used to shield bridge traffic railing ends, the barrier system may now be lengthened with the nested Thrive-beam guardrail and rigid post spacing. So this is all that's shown is quarter post spacing and nested Thrive-beam. So it's just a rigid stretch of guardrail. And then the extension may be used to connect to concrete traffic railing, which is shown on top, or thrive beam retrofits. And so it does help to have a detail explaining crash cushion to thrive beam retrofit connection. And so we went ahead and shown that. Now the extension is project specific, as needed by the designer to shield hazards to the full extent possible given project constraints. And so the idea for wanting to lengthen guardrail is you may have a hazard, an additional hazard that you're trying to shield besides just the end of the concrete. Typically with a bridge, there's a drop off in water, but you could also have a side street or a driveway that's preventing you from installing all the guardrail transitions needed, and that would be too long. But you still want to do the best you can as a designer, design it as long as you possibly can, and so that's where the project-specific length comes in. You basically make it as long as you possibly can. So previously we had two options for shielding bridge railings with crash cushion. As I was saying, we have the direct mount, which is basically a 0-foot extension, so that could be too short. You got the standard guardrail transitions. That if you add them all together, about 55 feet, that could be too long. So some intermediate length might be desired, and so simple approach would be this. This is all the same, and you also have an alignment curve. You just extend it all the way to the crash cushion, so it's pretty simple. So it's used where lengthening is desired, but where the constrained project conditions don't allow for the standard guardrail transition to W-beam, which is 21 foot long, about 22 feet, plus the approach transition connection to W-beam, that's about 31 feet. So that's pretty lengthy. You might not have room for all that. You need something a little shorter. And so in summary, use this to provide that intermediate system length when a direct crash cushion mount to the bridge traffic railing is too short, but when using the other standard guardrail transitions at W-beam, it just doesn't look practical or it won't fit. So, so that's the basic considerations for this. It's recommended when you're trying to extend, maybe 5 to 55 feet, and you just want a simple connection in there. So this type of explanation is also provided in the SPI Part G. There's some additional information in there, so that's new. All right, so with that, I got one more change to index 425031, adjacent barrier inlet. We basically updated the title, and I'll go ahead and explain why. And so the new index title is adjacent barrier inlet, formerly known as shoulder barrier inlet. So previously, we were coordinating these inlets with the type of barrier. So we had median barrier, shoulder barrier, and then curb and gutter barrier, and that all corresponded exactly to the type of barriers used. But the issue with that was calling this the shoulder barrier. It seemed to exclude it. Designers weren't picking up on the notes, and so it seemed like it was excluding it for median barrier usage when that's not the case. And really, this barrier can be used when the other barriers just simply won't fit, and you need an option where you're just putting this inlet adjacent to a barrier. And so that's the description for it, adjacent barrier inlet. This could be median or shoulder barrier. We're not trying to exclude any type of barrier, and so we wanted to make that clear. So we went ahead and changed the name. It's not only for shoulder barrier. One other thing to mention, so the 425030 for median barrier, it only covers a limited range of options. If there's an inlet only on one side, then 425030 doesn't cover it. And so for that case, you'd use this adjacent barrier inlet. And now you can use it for that case. And with that, finished my presentation. Again, if you have any comments, please put it into the comment field, and we'll respond to all of those.
Thanks, and have a great day.